The second video in the dividing unit is going to look at dividing involving decimals. There's two key breakdowns of this. One which involves dividing decimals by whole numbers, and then the other one which involves dividing either decimals or whole numbers by decimals. So one when the second number is going to be a whole number, and one where the second number is going to be a decimal number, basically. The first one I think is easier than the second one because you don't really have to do anything different from what you know so far. So if we look at wholes, first of all, 4.5 divided by 9, obviously the second number is a whole, that's why it's called dividing by wholes. You set up the same thing, bus stop, so the 9 goes on the outside, the 4.5 underneath. The only way in which this differs from, say, doing, 45 divided by 9 using the bus stop is that there's a decimal point in it, and all you have to do, first step, and this is all there is to it, is look at where the decimal point is, go straight up and put it in exactly the same place in your answer. So I've gone straight up and I'm going to put my decimal point there. Now I divide it exactly the same as I would a normal number. Does 9 go into 4? No, it doesn't. So I put a 0 above, I cross the 4 out. I didn't use any of it, so I've carried it across to the 5. Okay, even though it's going across the decimal point, it's the next number along, so that's allowed. Does 9 go into 45? If you do your 9 times table, you find that's 5. So the answer to 4.5 divided by 9 is 0.5. Number 2 then, 15.4 divided by 7, same thing again, bus stop, 7 on the outside, 15.4 underneath. Copy the decimal point, always do that as your first step. Does 7 go into 1? No, it doesn't. I carry the 1 across. Does 7 go into 15? Well, 7 twos are 14, so 2 whole times is 14 with 1 remainder. I carry that 1 across the decimal point to the next number, which is the 4. That now becomes 14. Does 7 go into 14? Yes, it does perfectly 2 times. So the answer to 15.4 divided by 7 is either 2.2 or 2.2, right? They're exactly the same number. Now the second case we're going to look at is involving dividing by decimals, which is a bit more tricky. Now to start with, I've shown you a little picture of a scale. This represents quite nicely a lot of processes that we do in maths. Now, this is not cheating, okay? I'm not just changing the numbers. What I'm doing the same to one as I'm doing to the other. Okay, so think of it as the scales or a seesaw. As long as you're being fair to both sides, then you are still keeping it sort of balanced. I've given you an example. If I times the left by 10 and I times the right by 10, it will stay balanced. Okay, I've increased both by 10 times as much, so it's still balanced between them. Now, first example is going to be 12 divided by 0.3. Now, whenever you see the second number as a decimal, what I want you to think is, can I multiply that by either 10, 100 or 1,000 to make that easier? The reason why we go with 10, 100 and 1,000, we could use other numbers, but they are by far the easiest numbers to multiply by because they've got special rules. So either 10, 100 or 1,000, and the aim is to try and make that into a whole number. Now, in this case, if I multiply the 0.3 by 10, then I get 3. 3 is a whole number, which I'm comfortable with working with, so that's what I'm going to do. I'm going to times the 0.3 by 10 to make it into a whole number. This means that I've also got to times the 12 by 10 as well, so that I'm fair to both numbers. So the 0.3 dictates what I'm timesing by, and then I copy that basically for whatever the other number is. So times the 0.3 by 10 to get 3, which means I times the 12 by 10 to get 120. So my new sum now is 120 divided by 3, and you can do the bus stop method here. I'm going to take a bit of a shortcut and just tell you what the answer is when you do it. You're going to get 40. Now what you'll find, okay, is that with divisions, as long as you change both numbers by the same amount, okay, you multiply them by the same amount, you will not change the answer, okay? And if you don't believe me, type in 12 divided by 0.3 on your phone or on your calculator, and you will find that the actual answer is 40. Second one then, 17 divided by 0.04. Again, the thing I look at straight away, which I don't like, is the dividing by 0.04. Can I multiply that by something to make it a lot easier to work with, either 10, 100 or 1,000. This time, I'm not going to multiply by 10 because multiplying that by 10 would make it only 0.4, okay? So that's why I've written times by 100, because multiplying by 10 is not enough. Timesing it by 100 will change it to 4. Okay, you move the decimal point 2 places to the right or the numbers 2 places to the left, either way you want to look at it. Obviously, I'm timesing the 0.04 by 100, then I've got to times the 17 by 100. 17 times 100 becomes 1,700. My new sum then, 1,700 divided by 4. For this one, I'd use the bus stop. 4 into 1 doesn't go, so you carry the 1 across. 4 into 17 goes 4 times, that's 16 with 1 remainder. 4 into 10 goes 2 times, that's 8 with 2 remainders. 4 into 20 goes 5 times. So whenever you're dividing by a decimal, what you want to be picking out, if the second number is a decimal, then you need to be doing that step whereby you make it into a whole number. So in summary, divisor is whole. Well, I'm going to use the bus stop and copy the point, like the first one. Yeah, that one's pretty straightforward. Copy the point, and then you do the bus stop, exactly the same. If the divisor then is a decimal, like the second example, then I'm multiplying it either by 10, 100 or 1,000 to make it a whole number, and I'm making sure that I do it to the other number as well. Okay, I'm keeping it the same. Think of the weighing scales of the seesaw. Once I've done that and I've changed it so that the divisor, the second number, is a whole number, then I go about dividing it exactly the same as I would any other type of number.